completing the square. So completing the square involves principles with the perfect squares. So first we need to understand perfect squares. So perfect square is anything that's raised to the power of 2. So we can look at basic examples with our whole numbers. So like 3 squared is just 9, 4 squared is just 16, and so on. So 9 is an example of a perfect square, 16 is an example of a perfect square. Now let's apply this to just an a plus b whole squared. Now a lot of people, they'll say that, okay, this is just a squared plus b squared, but this is a very common mistake, and I'll show you why. So if you were to actually expand this one out, be a plus b times a plus b. So each term is going to each one. So you get a times a is a squared, a times b is ab, right? Now looking at the second one, so b times a is ba, but that's the same as plus ab. And b times b is, of course, plus b squared. So we can see that in the middle we have two terms that are actually the same, and hence they double up. A squared plus 2ab plus b squared. So it's actually 2ab. So the expansion of a plus b whole squared is a squared plus 2ab plus b squared. Now this is very important to the technique of completing the square. So what essentially happens is we're saying that, okay, if we given an equation which has the a squared and has the b squared, but lacks the plus 2ab, we can just add it manually to make it look like a perfect square. Okay, so let's do an example with this one. So let's just say we have x squared plus 4x plus 1. Okay, now we can pretend that a is x, right? So a squared, and 1, we're not sure what 1 is, but we know that there should be a 2ab in the middle, right? So let's deconstruct the term that also has another a, which must be then 4x. So this is a. So let's have a go at this. So I have my a squared, x squared, all right? Then I have my plus 2. We're going to have a here and b here. Now what's a? Remember, we already established a, right? A was x. So 2 times x times something here must give me 4. So 2 times something must give me 4. Well, that something then must be 2, right? So then this is now 2. Okay? So that's 2, and the plus 1, we haven't done anything. We just write that plus 1 to the side for now. Now, what I'm trying to show you here is, well, we still need a b squared, right? So what if we add that b squared? So let's try that now. So plus, well, what's my b? Well, guys, my b must then be 2, since 2ab is 4x. So then 2 squared. Now, in maths, right, we can't just add something. Whatever you do on one side, you have to do to the other side, or whatever you do, you should have something that's the opposite to balance it out. So therefore, we must also do a minus 2 squared. Now, it seems very paradoxical to do plus 2 squared minus 2 squared. It's just to keep it balanced, but don't dwell on that, because if you recognize, here is our perfect square. So I have with me right now my a squared, I have my 2ab, and I have my b squared. So these first 3 terms, we can just transform them straight away, just immediately, into a plus b whole squared. And what are we left with? Well, I'm left with a minus 2 squared, and I'm left with a 1. And this one we can just simplify ourselves. Minus 2 squared is minus 4, and then plus 1, that makes it minus 3. So the final answer would be a plus b whole squared minus 3. Okay, let's do a different example, because there's one more principle I have to show you. So let's say I have 2x squared minus 4x minus 5. Now, the problem is, because I have that 2 in front, I can't actually do the perfect square, because if you remember, it was always an a that we dealt with, right? Like just an a on its own, a plus b whole squared. There's no number in front of the a. So now we have to be creative and manipulate this to make it just by itself. And the way we do that is just factor out the 2. Whatever coefficient is stuck there with the x squared has to go. but of course, you're going to have a lot of downstream effects. So, of course, if I take it from the x squared, it's just x squared. Now, if I take the 2 from the 4, I'm going to be left with 2x. Now, if I take the 2 from the 5, now I normally just leave this in fraction form, just 5 over 2. And I recommend you do that rather than decimal, just so you can keep track of what you've divided by, just in case the simplification gets easier by doing that down the line. Okay? And now we can do our completing the perfect square just the same way, just being mindful of these brackets. Okay? So let's do the same thing again. So x squared minus 2ab. So what's my a? Well, if I have x squared there, then x squared must be my a. So x must be my a, so this is x. Well, then you think, okay, what would go here? So 2x times some box should give me 2x. Well, that must be 1 then, right? So that's a 1. One thing I also want to point out before I move on is the sign that is here. So whether it's plus 2ab or it's negative 2ab must match the sign you put there. So in the previous example, it was a plus, hence a plus, whereas in this example, it's a negative, hence a negative. Okay, moving forward. So, okay, so I've identified my b is then 1, right? So let me just very sneakily add a 1 squared. Now, of course, I can't just add a 1 squared, so I should also take away the 1 squared. And that negative 5 over 2, I haven't done anything to that one, so I'll just keep that there. Okay? Now what we can do, so just keeping the initial 2 there, is, again, those first 3 terms can just become straight away one nice perfect square. So x minus, remember, because minus, so a minus b, so minus 1 whole squared. Now what are we left with? Minus 1 squared is just minus 1, and then negative 5 over 2. Okay, so you guys can do this with your calculator. So again, we'll have the 2 here. We have our beautiful perfect square that we've just derived, right? And then this one will just become negative 7 over 2. Okay, and we'll just close the brackets, and we can just expand it out again. So this will then become 2. So the return of the n is 2, x minus 1 whole squared, and the 2 and the fraction will cancel out and just leave it with 7. So there we have it. That's now completing the square for this one. So one last thing I'll show you, and it's not so much adding a new thing, it's just showing it to you in a way that's probably more useful and that you'll see more of. So it's for solving. So solving is much more useful. You see it in quadratic questions all the time. So let's say x squared minus 6x plus 8 equals to 0. So we're basically trying to solve it. So if there's a parabola, we're trying to find the x-intercepts. Okay. Now we can do the same technique. So let's go ahead and do x squared minus 2x, and then something, right? That's something. 2x times something must give me 6. So that something must be 3, right? So let's write 3. Okay. And I'm just going to add that 3 squared, and then that plus 8 is still there, right? Now, in the past, I used to just do a minus 3 squared, right? You can still do that here, but since it's an equation, it's much more efficient to just put it on the other side. So, because I've done a plus 3 squared, I can do a plus 3 squared here. Now, you might be wondering, okay, why is this one plus and why is this one plus? Well, whatever you do here, you do on the other side. And if they're both plus 3 squared, you can just minus 3 squared. So if it's going to be on the other side of the equation, it has to be the same sign. Okay? So I've added my 3 squared there. And just like always, those first 3 can immediately become the perfect square. So x minus 3 whole squared. And plus 8, I haven't touched that one. And this one I can begin to simplify. So 3 squared is just 9. Okay? Now let's clean this up a bit. So take away the 8 to the other side. So what are we left with, guys? So on the left, x minus 3 whole squared equals to 9 minus 8, which is 1. Okay? Now let's say we're trying to solve x minus 3. You just do a square root, x minus 3 equals 2 plus minus square root of 1, which is just 1. Okay, you might be wondering why plus minus. So let's say x squared equals to 4. I don't know what x is, right? So x is 2. but it could also be negative 2, right? Because negative 2 times negative 2 is also 4. That's why I include that plus minus. Okay. Now, bringing the negative 3 to the other side, just adding 3. So we have two options, right? So let's not get confused here. We have this one, or we have this one. So adding it to the first one, that leaves us as x equals to 1 plus 3, which is 4. And the second one is x equals to negative 1 plus 3, which is 2. So those are our two final answers. Hope this helps.